I just had to let you know you're.
My name is Muhammad Nama Syafiq bin Abu Yazid. My metric number is 1240845. I'm going to present the third question for assignment 3 SOA. The third question is an actuarial evaluation compares two types of growing endowment perpetuities issued by a trust fund, both yielding the exact same annual rate. The first perpetuity, which is perpetuity immediate, promised an initial payment of 500 1 year from today, with each subsequent annual payment growing at a compounding rate of 4%. The present value of this first asset is 9,500. The second perpetuity, also a perpetuity immediate, begins with an initial payout of 400 ringgit 1 year from today, but its subsequent annual payments increase by a fixed linear amount of 20 every year. Find the present value of P of this second trust asset. Okay. The goal of this problem is to find the present value of the second asset. However, the problem gives us a shared constraint. Both assets yield the exact same annual interest rate. Our strategy will be divided into two main phases. First, we will use the data from the first asset, which has a geometric growth pattern, to solve for the unknown interest rate I. Once we have that rate, we will apply it to the second asset, which grows arithmetically to determine its total present value. Okay, let's look at the first asset. First, we're going to draw the time diagram. It is a simple perpetuity immediate time diagram. Above the first year, we're going to write the 500 and the PV is 9,500. The common date is below the PV. The initial payment of the first case is 500 ringgit. The payments grow at a compounding rate G of 4%, or 0.04, and the PV is 9,500. For a perpetuity with geometric growth, we use the formula PV equal to R over I minus G. Substituting our known values, we get 9,500 equal to 500 over I minus 0.04. To solve for I, we multiply both sides by I minus 0.04 and then divide by 9,500. This simplifies to I equal to 0.0926316. Now that we have successfully identified the annual interest rate, we can move on to the second trust asset. The time diagram for the second case is also perpetuity immediate time diagram. Above the first year, we're going to write the 400 and its increasing amount is 20 ringgit every year. So above the second year, we're going to write 420. The initial payout for the second case is 400 ringgit. The fixed annual increase Q, which is 20 ringgit, and our calculated interest rate I is 0.0926316. Okay. For the formula, present value of an arithmetically growing perpetuity immediate is PV equal to R over I plus Q over I squared. This formula essentially split the value into two parts: the value of a level perpetuity of 400 ringgit and the additional value created by the 20 ringgit annual increase. Okay, so now let's plug in the numbers. First, we calculate the base component 400 divided by 0.0926316, which equals to 4,318.80. Next, we calculate the gross component RM20 divided by 0.0926316 squared, which equals to 2,330 ringgit and 84 cents. Adding these two values together, we get 4,380 and 80 cents plus 2,330 and 84 cents, which equal to 6,649 and 02 cents. The present value of the second trust asset is 6,649 and 0 to cent. In summary, by identifying the shared yield rate from the geometric perpetuity, we were able to accurately price the arithmetic perpetuity. This concludes our evaluation. Okay, thank you.